What's up, everyone? My name is Melkey. I'm one of the instructors here at Frontend Masters. I'm also a content creator and I write Go professionally. And this is going to be a set of small follow-up series or tutorials from the Complete Go for Professional Developers course that's live on Frontend Masters right now. So just as a quick follow-up, this is the course. It was a 2-day workshop where we built an entire Go application from the ground up. So if that's something you're interested in, I definitely recommend to go check it out. And if you are wanting to follow along on the code, there is this GitHub repository called Frontend Masters Project Live. You can see here, it's the workshop code that we used in that 2-day workshop about all the things we have here. As you can see, there's Docker files, internal migrations, and we're gonna be following up here with a few topics that we didn't get a chance to cover in the live workshop. And the first thing I wanna add is optimistic locking. And this is a pretty popular topic when it comes to updating fields on very high traffic areas. So for example, think of Ticketmaster, and you wanna sell tickets in a stadium. Well, there's a high chance or a likelihood that two people may buy tickets for the exact same seat at the exact same time. And then you have to decide, well, who will get that ticket? Or in another way, if you want to update something and two people want to update the same field, who gets the actual right to update it? Because you get this potential leak in the state from time X to time X plus 1, and it gets more complicated the more people you have modifying the field at the same time. So we have these approaches of locking the database or the row before we make any changes. And there's different mechanisms that go into locking this pessimistic locking. Here we're going to go with the optimistic locking approach. And this is a bit more simple because all we're going to do is essentially add a new field to our schema. So just as a refresher, we have all of our schemas defined here. And all we're going to do is add this new column called version. And version, its responsibility is going to be continuously updated anytime somebody makes a change. And if two people make the change at the same time, well, then we can see if the previous version matches the version at the end of the operation. And if it doesn't, we can cancel it because there's been clearly a change of state in between the operation, and we can use this version to continuously monitor the state of the rows in our database. So in our application, we have this workouts table, and we're going to add a new field here. So let's go ahead and add this new field. So go into the migrations folder and add the new field. We're going to do 1, 2, 3, 4, 5, and then 6. So 4 zeros and 6, followed by workouts version control.sql. All right, and what I like to do is go ahead and just copy all of this from the previous workout SQL, just paste it here. We're gonna be deleting a lot of it, but it adds a lot of that boilerplate that we need from Goose. So we need the Goose up command. And in here, you can go ahead and just delete all of this like so. I'm gonna do alter table, workouts, add column, version, big int, not null, default 1. And then on Goose down, we're gonna do alter table, workouts, drop column, version, like so. Okay, and you can see here, when I ran the application again, I automatically got that version control update to version 6, but go ahead and use the Goose migration command if you wanna not kind of tear down your database and re-update it. So we covered that in the course, so go ahead and check that out. Okay, and after that, the main place we want to upgrade or update is actually our workout source. So go ahead and open that up. We're going to be adding the new modifications to our workout struct here. So we can do version int, add our JSON tags, like so. So there's a few areas that we need to modify and some of these functions that are defined in our interface. The first one that we're going to be modifying is get workout by ID, because now when we want to query and pull a workout, we also want to make sure that we're pulling that version associated with the last update for that workout itself. So here we can just add version, okay? So we're going to add that into this initial query. And then down here where we're going to run query row, we're going to do workout.version as well. We're going to populate that field. And that's really it. That's the only thing that we need to modify in the get workout by ID. And now the next area we need to update is the update workout. Okay, and in the update workout, it's going to be a little different because every time we make a change to our workout, this is where that version control, that optimistic locking is going to come into play. If someone wants to modify a public workout record, like change the title or description, we want to make sure that we also uptick the version number just in case if two people update the same workout, the same field or different fields, we can rely on the version number to determine if it's a suitable update or not. Okay, and over here in the query, right below the transaction rollback, we can go right after calories burned. We're going to update that version. So we can do version equals version plus 1, like so. All right, and now we're going to do where ID equals 5 and version equals 6, like so. Okay, and we can also do returning version because that's going to be necessary for our handlers, our API handlers on the letter above to make sure that we are processing the version we update. All right, and following that, we can just create a new variable, something like var new version. We're going to make that into an int. And then here, instead of exec now, because we're going to be returning something, we can do transaction query row. Okay. And right after workout ID, we're going to do workout.version. And then here, we're actually going to scan into, because we're returning from our query, the version, we're going to scan in to the reference of new version like so. Okay, and then you can see we have a variable mismatch. And that's because it no longer responds with result, but just an error like so. Okay, and we can go ahead and delete all of this because now in this error, we're going to make this a little bit more verbose. So if our error does not equal to nil, okay, then here we're going to do if error equals SQL.error no rows. We can return SQL error no rows, like so. And that's pretty much all we need to do with for our workout store. And now we can actually head up to the API layer and make the modification there and actually use the result from the version SQL result. So let's go ahead and go into the workout handler here. We have this function called handle update workout by ID. And this is now where we're going to have to modify the version and add it here. Okay, and the first thing I want to do is right here, we're going to add this new field called version. It's going to be int. I'm going to do JSON version, like so. Okay, and after we added this, if you remember, we have this existing workout just to make sure on a previous check that what we want to update actually exists. And the only thing we need to do is put existing workout dot version equals update workout request dot version. Now, and this is the only thing we need to do. And you may be asking, well, what's the magic? Well, if I go back to the workout store, the entire magic is here. So when we want to run this query and we want to update the workout, we're stating here for the where condition, where the ID of the workout and the version number matches the version number that we have stated or saved. So when you pass the version number from the update request, we are going to pass that into this query, and this will only work if the version number here that we pass in matches the one that's stored in our database. So the next thing I want to do here is actually cover SQL query timeouts, because you can see here I'm in the workoutstore.go and we have a lot of queries here, and these seem to just kind of run. We have our transaction of query row where we pass in certain values and the query itself, and we handle the errors, etc., etc. However, if you remember back in our main.go, when we first started this course, we created something called an HTTP server with a few timeouts: an idle timeout, a read timeout, and a write timeout. The only issue is these timeouts are kind of long, 10 seconds and 30 seconds, 10 seconds to wait for a read to timeout and 30 for a write. That's a lot of time, and that could possibly be a bad user experience. And a lot of things can happen in 10 seconds, let alone 30. And so what I want to quickly introduce here, as we go back into our workoutstore.go file, is introduce this concept of really closing in on individual functions that have queries within them and time those out separately, then timing out another function that may need a more time. But if you want to quickly just look something by ID, that should be a pretty simple and fast operation. And if you know if something is taking longer than, let's say, 3 seconds, you know something probably is going wrong, or there's an opportunity for you to optimize. So you can see here, we're in this get workout by ID. And the first thing that we're going to do is introduce our context. You can see here, we'll do context cancel. We're going to bring in the context package. And I'm sure if you've written Go, you've probably heard of the context package. It can do a lot of things. It can hold different values, but it can also handle timeouts. And so here we're going to do with timeout. And the first argument is the existing context, and that's going to be context background. So this is the kind of context that exists in every thread within Go. And then here, we're going to give it our timeout. So I'm going to do 3 time dot second, meaning I'm injecting a new 3-second timeout on this new context I'm going to use. And then here, we're going to defer our cancel function like so. Okay, and now we're complaining that we're not going to use our context anywhere. But the only place we actually need to make a modification is actually where we make transactions with our database. So you can see here, we have one transaction here for the actual workout, and then we have the list of entries. And I want both of these to have that same 3-second timeout. So here, we're going to modify this function from query row to query row context. You can see here, query row context executes a query that is expected to return at most 1 row. Query row context always returns a non-null value. Errors are deferred until row scan method is called. If the query selects no rows, we'll return errors. Otherwise, scans the first selected row and discards the rest. So it's pretty much the exact same function as query row, but this time we're passing in this context in the function signature here. And the only other change we need to do is place context like this, and let's make sure we call in the function. And there you go. Now we have this query row context. We're passed in that context, and now it's going to work exactly the same. However, it has this more strict 3-second timeout. And we can do the exact same thing here. Instead of query row, we can do query row context and pass in the context like so. And that's it. And that's really the only thing we need to do for our get workout by ID function. And it now will execute within the 3-second timeout for the context we created within the scope of the function itself. Now let's actually do one more called the update workout. It's going to be the exact same thing. Let's do context cancel. It's going to be context with timeout context background. So the background that you can see here returns a non-null value. It is never canceled, has no values, and has no deadlines. Typically used by the main function initialization. So it's pretty good practice to kind of create separate context if you want. However, you can always kind of rely on this context background. And here we're going to do 3 time dot second. Like so. Make sure we defer the cancel. And now we can inject that context into our queries. So here, instead of query row, we can just do query row context, ctx, like so. And in here, we can do exec context. You can see it's going to error out. We can just do context and the rest of the query. And same thing here, exec context, like so. And that's it. And everything kind of remains the same. Now this just adds more flexibility. And like I said, I think it's good to have contexts for functions and queries that you know shouldn't take a lot of time, which can amp up the user experience. Now you can use this and kind of spread it throughout the rest of the functions here. I'm not going to do that. But now you know that you can inject this custom made context from the main context thread from a main function and modify from 3 seconds to 5 seconds or however many seconds. You can make this 2 seconds or even less. And you can see if you're constantly timing out, then you know you can increase the scope of your context. All right, so I hope you guys enjoyed this kind of tutorial where we update the SQL context timeouts as well as add an optimistic concurrency mechanism to the complete course for building backend web apps with Go. Stick around for another tutorial where I'll be covering concurrency and a follow-up. So I hope you guys enjoyed this and make sure you check out the course. Let me know what you think.